platform here at New Desert. And I started this meetup because I wanted to meet people who are actually using GCP, which is kind of rare at the moment. Hopefully that's going to change very, very soon. And to try and evangelize GCP, I truly believe it's the better cloud option for most people.
I'm Jared. I'm one of the senior consultants here at New Desert. I've actually been doing mobile mostly over the last year and a half, doing Xamarin specifically, but I love cloud. I'm AWS certified just because it was something that was interesting to me, and I kind of wanted to control my future. I'm working on Google Cloud certification for that same reason, and I really do find Google to be, like he said, the better of the clouds. I don't hate AWS, I don't hate Azure, but when I was using GCP, it was just more intuitive to me. So I was like, all right, I want to learn more about how to use this because I think I can be more efficient using it, and that's why I'm here.
AWS got that per second billing now, though.
That's true.
Yeah. And so does Google, and so does Azure. So, you know, I mean, it'll be sub-second soon enough.
Yeah, I'm Andrew. I'm also associate consultant at New Desert as well too. Kevin and I have been working on the same projects together, so I've seen the struggles and he's seen my struggles as well. Yeah, so I'm actually curious on. I'm new to the cloud in general as well too, so I just wanted to see what it has to offer. And with Matt here, we're all working towards that GCP certification.
Well, Matt's certified.
Yeah, well, I'm working towards it. Yeah, you're working towards it.
It's hard to do when you're available.
Okay, so I am Seik Narvaez. I'm a senior solution architect with MongoDB.
Okay.
I'm my third year now with the company. Before MongoDB, I used to use a lot of Azure and mostly Microsoft in the background. And now MongoDB NoSQL, mostly AWS currently. Since we just launched Atlas support in GCP and also Azure and AWS, I really want to learn more about GCP. Actually, one of the things that I want to apply right away is I have a talk that does serverless with AWS, Lambda, and Atlas as the backend. I want to do the same talk, but do it with Azure, with GCP. So we're asking about the endpoints and the serverless functions. So you want to get into that?
Okay.
Yeah.
Okay, I'm Gilberto Velasquez, senior consulting engineer for MongoDB also.
Okay.
Okay, so actually he invited me, but I was actually interested in GCP given that in the field I usually find the most basic deployments of MongoDB based in any of the clouds, Azure, AWS, GCP. So I was actually more interested in learn a little bit more about GCP.
Okay, great. Thank you for everyone coming. I may want to ping you both later because I'd love to hear more about what you find about Mongo running on GCP. So if you're willing to present in next month or the month after, I would love for someone else.
Yeah,
other than me to do it.
I'd love to do a talk on Atlas with GCP.
Yeah.
Let me get my feet wet, or we can get somebody to come down.
Yeah, absolutely. And I can point you to resources within Google as well.
And I also run the Mongo user group, so it should be ready for me to combine with the event.
Okay, very cool. All right, awesome. So let's get started. Well, we can kind of skip this one because you already know we did that. But first of all, question. I mean, how many of you have actually worked with containers? Yeah, pretty much everyone. Well, majority now, right? Come on. How would you define a container? Anyone want to come up with a definition they use internally?
Something less than a VM.
Something less than a VM, yeah.
Usually I call it black magic.
I mean, maybe if you guys define what a container is, maybe I've used it in some way.
You may well done, yeah.
Pretty much a VM that has no operating system.
Yeah, kind of, I guess. So Docker, the company, does have a definition for what a container is. A container is a lightweight, standard, blah, 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 blah. Basically, it's a little package that contains everything it needs to run, right? It just needs an operating system that can push a thread through it and start launching it and provide all the services that are not within the container, so networking services, storage services, things like that. Basically, it's a tiny little image. So most of my images are trying to get to be about 10 meg, 15 meg in size, which is obviously very different than you get if you're running a VM, which could be 5, 10 gigabytes in size.
You get people out there.
Oh, really?
Will we get them?
Yes, please. Door will open.
Is it lock or something?
Oh, yeah, I got it. Did you ready?
Sweet. 4 people.
All right. Hi, welcome. I'm Matthew.
Devin, nice to meet you.
Good to meet you, Devin. Please take a seat. We've actually just started. There is food if you're hungry, but we'll get kicking off. So we just defined what a container is according to Docker. Okay.
I think one of the things too about a container, though, they can spin up and spin down relatively quickly.
Absolutely.
Right?
Yeah, without a doubt. I mean, that's the whole premise of the auto scaling that we want to do, is that a VM would take forever.
Right.
Container you can launch up and down very quickly. Yeah. So on Google, there's a handful of different ways. Well, a handful, 3 real ways of deploying Docker. So you can go the old-fashioned route. We can spin up VMs that contain either Linux or Windows, and you can install Docker on them. Or you can get a pre-optimized image that's ready to go with Docker in it. But you are managing everything. It's just like having a data center. VMs need to be managed. They need to be taken care of. If you don't do it, no one else is. Right? This is where a tool like yours comes in to alert you when there are problems.
Sorry.
But you're still fundamentally managing a fleet of machines. My practice these days is just to say, no, we do not do containers on IaaS unless the customer has a specific reason to do so. Sometimes they do. There might be something they need. They absolutely must run Docker Swarm. Then IaaS on GCP is the only option. Maybe they've got to customize it and make it run just so for their workloads. All right, fine. But for most people, that's not the way to go. Okay. So kind of a middle option, if you're desperate, is to use App Engine. So App Engine's designed to take a bunch of Go files or Node files or whatever and package them up and run them automatically. Now, the way that it does that is through containerization. So when you say gcloud app deploy, it looks at your YAML files. It sends them off to Container Builder, which is another service within Google that creates a container, and then it runs the container itself. Now, that's great because you don't need to do anything. The bad news is that you can't do anything with it. It runs when Google wants it to run. It runs a number of instances that Google wants it to run and things like that. So you can't do a lot of tweaking or fine-tuning with it. So, I use my cute Hannibal here. If you can live within the restraints, sure, it's great, it's cute, it works well, but it's not going to scale and it's not going to do what you need it to do. All right. Oh, give me a little example. I forgot I did this. So just again to show how simple it is. To run a container I'd already created called Hello Container. It doesn't do a lot. It just says Hello Container. These 4 lines are all that it took to get that running on GCP and for it to scale automatically. If I hit that URL enough, I will see Google scale that container and run more and more and more as necessary to satisfy the requests. But I have no say over how it does it. It's up to it. Okay, so is that a hop link? It is. There you go. That's all it does. All right. Oops, skipping ahead. So the final option that you get under GCP, and the one that we're pushing everyone to use within our practice here, is what we call CAS. Well, not only us, but CAS. So it's containers as a service, Kubernetes. Right. We know from the product development team that they've been using it 4 years now. Is that right? Yeah, we've got some people who really know this stuff in-house. But it's
obsess over it in-house, you mean?
Well, that's their job. They're allowed to obsess. So I haven't got time to obsess. I love it from a distance. So it's a full orchestration and control package. So just about anything you can think that you need to do to keep an application running, or either do it or offer you a hook to manage and do it yourself. So Kubernetes itself came out of Borg, which was an internal project at Google. I believe they still use that internally. It's not quite Kubernetes. It's something they're not willing to share, something custom. But Kubernetes is based on that, and it's something that they've open sourced and allowed the rest of the world to use. Quite frankly, it's probably the It is the industry standard right now. The things you see Docker doing with Swarm and stacks and things like that are playing catch up, because this has become, the options that you get and the flexibility that you get has become ubiquitous. So a product that was launched by Google and open sourced, it's now available on Azure, and it soon, more than likely, will be available on Amazon now that they have joined the steering committee that runs this. Does anyone use Kubernetes? Apart from you, Kevin, I know you've used it. Okay. I know you must have customers that are
Yeah,
using
we have
it.
customers who absolutely use it.
Yeah. And how did your tool hook into Kubernetes and give us all the metrics? And
Yeah, so you can look at all the pods, all the nodes, what's running. So if you're like running Mongo inside of that, do an auto discover and be able to show the performance of both the service running, container, everything.
All right.
Yeah, we have several customers that are using Kubernetes. Actually, one of our solution architects, one of my peers in the UK, has a blog, actually now a dedicated blog only on Kubernetes with MongoDB.
Oh,
Which is getting really popular, I think, in EMEA.
yeah, again, I'd love to see more information
Yeah.
about that, because that's something that's very interesting, because we see people using it, we encourage it, but there is a curve associated with it that can be a little overwhelming, and anything that gives you visibility into the product is a godsend, I think. Okay. So having established that this is the one we want to do, the rest of the talk is about Kubernetes. I'm deliberately keeping it light, just because Kubernetes itself can be quite a topic to get into. Talk about it another time, but since we're starting with just containers, I'll keep it pretty light. So you can create a cluster pretty easily within GCP, either from the command line or from the console. I'm going to go ahead and actually create one from a command line, because I've got a shell script that'll do it for me. Let's do max. Why can't I type when people are looking? So that's going to spin up and take a little while to run. Oops. Oh no, tell me I'm in the wrong project. Let's see. It's fascinating, right? Oh, that's not good. That's from the last time.
Login, right?
Yep, you're right.
Damn, the AC correcting the director.
That means he's been using it. That's good.
Well, I mean, I sat here for hours, like smashing my brain against my keyboard.
The best way to learn it, though, is to just use it.
Oh, come on, Chrome.
Demo bots.
There we go. Got it. All right. Oh, no, that one. That's the wrong one.
So you can turn into 2 accounts.
That's what I get for trying to be clever, right? This is the Udesic one.
There you are.
Yeah, I'm not using my personal account for this. This might actually cost money. So Udesic can pay.
But you don't want to spin up a million containers under your
No,
account?
not really. All right. Knew there was something I forgot to do before the meeting started. Minus.
No pressure, but don't mess up.
Oh, okay.
performance start counting down, so no pressure.
This is part of my killing time technique because I talk too fast.
Had to turn a 20-minute demo
Yeah.
into an hour demo.
Yeah. GQPZ. Of course, that's a 0, right? 6U. Ooh, okay. Just gonna be-
Wait, so are you running Termux within an emulator?
This is, yeah, within my Chromebook, yeah.
How do you emulate Android on a Chromebook?
Some of the Chromebooks support Android apps now.
Okay.
So this one supports it.
Interesting.
Good catch.
Yeah.
I hadn't even caught it.
I forgot they released that.
So I'm trying very hard to love this.
Right.
I'm trying.
That's why they did Chromebook. It doesn't have better.
Yeah, my I mean, I'm talking about things I shouldn't
so
be. talking about.
confusing to me why they didn't give it a command line interface. Right? It really wouldn't be.
This will just make sure I don't do anything stupid. Yeah, my kid went off to college and I gave him my real laptop. Okay, I can live with a $180 machine. That's fine. What the heck was I doing anyway? Oh yeah, I'm running my shell. Okay, for this. Oops. All right, now let's try Max. Hopefully that's all good. All right, so we'll come back to this in just a moment because my G-Cloud needs to be updated. We could do it through the UI, but it'll actually be quicker to do it this way once it comes up. So while I'm waiting for my machine to catch up, any questions so far or interesting comments to make?
When I went to the Google platform onboarding thing, because they have self-healing, I guess, pods as part of a cluster, they created a web interface to basically play Whack-A-Pod. So they just like click them, knock them out, and then watch them regenerate.
Oh, which you told me about. We could have done that.
Yeah.
It's more interesting than the idea I came up with.
I would have taken a lot more time to set up though too.
Yeah, well, as it is, I ran out of time, but yeah. There you go. What can you do, Greg?
Next time.
Next time. Yeah, don't be coding the minute before the meetup starts. All right. Anyone else, any questions? I know people coming and hoping to pick up information and ideas. So
you were talking about, was it Docker or AWS that has a theoretical competitor to Kubernetes, but they're still playing catch up?
Yeah, so ECS was arguably the first one in the space. Great technology a few years ago, and that's the best I can say about it. It's very, very limited in what you can do. They keep adding things on to make it better, but it still feels like a bolt-on to the rest of AWS. So if you are tech at AWS, you know about load balancers, you know about VPCs, you know about all of that stuff. It's fine. You can make ECS work very well, and it'll integrate if you've already got CloudFormation templates set up and you're already deeply embedded in AWS. Absolutely, ECS is the way to go because it fits. In, trying to do something new, trying to get something up and running, it's a beast. I mean, compared to ACS is like 4 commands to get something running. Google's the same.
So if you give you better or equal to performance to someone who knew what they were doing with ECS, or? So
performance is a really loaded term.
Yeah.
What VMs are you running? What kind of network options are you running? All this complicated in AWS because there are different price points for each of those items, right? Google will give you a fast network. or a slow one now. We'll give you a cheaper one if you really, really want it. But internally, everything runs at the same. Amazon doesn't do that. They give you different price points so that they can optimize their income, I guess.
Makes sense.
So it's not that it's a bad tool, but if you're coming from Docker, if you're coming from something where you're used to just doing Docker Compose or Docker Stack Deploy or something like that, ECS is very complex.
Okay, makes sense.
You know? So it's interesting you said that, because I've had to do that for a paper we're working on as a company, is comparing some of these alternatives. And
Probably
yeah,
interested in reading that.
yeah.
Are you looking at like Mesosphere too? As part of that?
Not really, because of who's sponsoring the content. Although I'm interested in
They
learning
now
more about
support
it.
Kubernetes as well.
Yeah, it makes perfect sense. I mean, they can be the abstract, the base layer for everything.
That's
So.
right. Yeah, they had to do that.
Mm-hmm.
Right.
Exactly. It's a lot like OpenStack. It's no longer its own unique thing. Now it's you to apply what you need on top of it. Yeah.
So later I'll show you if you want. We do have a short video.
Very interesting saying that. Yeah. Absolutely. We have a minor break right now. Yeah.
And Apple TV, right?
What's the equivalent of a VPC peering in GCP?
So everything in GCP, everything is its own project, right? You can do networks, you can do sub-networks. If you want to do peering between them, it's just a matter of making sure that the ingress and egress rules allow it, and that you've assigned both projects that allow the communication across that. So you can do it. It's a little more straightforward. What it doesn't have is some of the more exotic networking options you get in Amazon. Amazon's just more mature. Again, this is in my experience over the past few years, very few people with options. So something like GPC is usually a better choice. GCP, sorry.
Okay, Hunter.
Oh yeah, I remember that.
What?
GPC.
Yeah.
Oh yeah, that's probably where I'm getting from. One of our client execs always says that. Now I'm saying it. It's not good.
Google Cloud Platform.
Yes. Well, at least you can say it. Okay. All right. So, well, you can see it now. That is essentially what the shell script was doing anyway. It was just run that command that echoed there. And this is going to take a few minutes to get going, so I'll assume it's going to work. That always works, right? And just see it here. Come on, Google. Still going. All right. Go back to this because I made a note to myself. This takes a few minutes. All right. Moving on. This is the application that I'm going to be deploying into this cluster. So it's actually a very simple application. I'm arbitrarily making it more complex just because we want to demonstrate that it fails under load and all the rest of that. So it's basically a Go service that calculates the digits of pi. So there's an algorithm out there, I forget the name of it, but it's very clever, where you can digits of pi at a given offset without needing to calculate all of them before it. So I can go and ask for the 1000th digit, and I don't need to calculate the 999 that came before it. So some mathematician found out that there's a way of doing this because of power series and other clever stuff that I pretend I understand. So it's a good example of an application that can be parallelized, that is good for the cloud, right? Because if I need to get 1,000 digits of pi, I could spin up 1,000 instances and ask each of them for 1, or 100 instances, ask each of them for 10, whatever. So somewhere in between is what we're actually going to be doing today. However, to make it deliberately more obtuse, the calculations actually calculate in blocks of 9. So whenever you ask for a digit, it gives you 9 digits starting at that point. Well, there's no point in asking for the other 8 if you've already calculated them. So we store them in blocks of 9 in a simple Redis cache. If you've ever used Redis, you know that it's a very simple tool. It's definitely no database, no document database. But as a simple key value store, it's pretty good. I'm running it in this configuration as a single master with a number of read-only nodes on the end of it. So the Sentinel service, that kicks in, that looks at all the nodes in the system and figures out which one's the master at any given point and which ones are the read-only slaves. And if something happens to the master, promote a slave to become the new leading one. Again, if you've ever used ever used Redis, you know that Sentinels need a known starting point. So we have a single node that I call the bootstrap in this case, but really it's just a Redis instance that is being run to know that it's the master. So it starts off as a master, and then the Sentinels and all the other reads know how to connect to it, and then they'll work as a cluster once that happens. All right, does that make sense? Everyone worked with Redis before? I mean, database guys probably have. But no? Okay. It's magic.
I believe you.
More magic.
Yeah, it is. Absolutely. So this was chosen because I'm working on a project for the company. I was saying where I've got to evaluate a bunch of these different ones. So we wanted something that was fairly simple to get up, but would solve, that was chatty enough to give us network issues. So, what we're alluding to there is every time I make a change to the master and I insert a node, insert a digit, it's got to replicate that to all the other instances, and that causes cross-node traffic that can cause problems within the system. So with that in mind, I'm going to check how we're doing here. Up and going. Oh, it's done. Okay, great. All right. So we actually have a cluster up and running that has just 3 nodes in it. All right.
So are each of these nodes contained in a container, or is it?
Think of these as the VMs. So these are your machines that are out there ready to run an application.
So there's 3 VMs running.
There's 3 VMs running. Right now they're empty. There's nothing actually running on them. So what I'm going to do is, oops, wrong way, is I'm going to go ahead and deploy these applications. So as you saw, each of those boxes, I've got a separate YAML file that defines each of those boxes, and then go from there. Could be one big file, but I like to do things separately.
And then these applications will be run in a container separately, right?
Yes, each one will be its own container, but I've only started 3 nodes. But there's a total of 7 containers I'm going to be running to start with. No, sorry, 9 containers I'm going to be running to start. So the Bootstrap is a single Redis instance. I can launch these in any order. I've made them all wait for the other ones to start before anything happens, but create. Thinking maybe I'll go get the real laptop. Admit defeat.
Worked last week. or last month.
It did, but that was just functions. That was Node. That was easy.
Guess this is a little bit more intense.
The little Chromebook that could.
It's trying. I think I can. I think I can. There we go. Bootstrap's done. That's better. All right, so now that's running. Let's go take a look and see what the cluster's doing. So I live on the command line. I don't know how many other people do that, but the web interface drives me crazy just because it's slow, but it is prettier to look at. It does convey the information a little bit better than YAML
It's
does.
oftentimes easier to understand when you're beginning Cloud.
Yes. This will take a few minutes. What's happening, in case you're questioning, is that the Bootstrap's up and running. 1 out of 1 is running fine. Everything's good. I've told Kubernetes to ping each node, each container, and ask it if it's ready to accept connections yet. It does that with Redis by checking on port 6379. It does that on my Go application by checking on the HTTP port it's listening on. Once they're all responding, and it only checks every 30 seconds or so, then this will turn green right the way through. Okay. So PyServer is dependent on the other ones, so this is going to be the last to start up.
It'll happen the next time you refresh it.
You think so?
Yeah.
So as of right now, no.
There you go, Joe.
You refreshed it in a long time.
You think so?
No more GCP for you. Ow.
I'm like that last minute code change. Did I break something? No. Okay. Yeah, so I got my math wrong. That's not good. Right now it's running 7 containers. Right, we got 1 Bootstrap, 3 read-only slaves, and 3 Sentinels. So there's 7 containers running on 3 virtual machines. Once this is up and going, there'll be 12 total running on the machines. Oh, okay, so all 5 are running. Just hasn't passed the aliveness test. Let's take a look at that and see what it's doing. No. There's some chairs there.
I can grab more if you need more.
Yeah, we can always bring more in. So it's still. All right, now we're good by the looks of it. Status is okay. We got 5 out of 5 running instances. So of course I like to test. The things I didn't get finished in time was a nice UI for this. So sorry, this is another command line tool. But what I'm going to do is have it hit the service here. Oh, did I talk about? I didn't talk about services. Okay. So when I set up these containers, one of the things you can do in Kubernetes is you can define them as services. And services gives you a way of essentially naming and load balancing containers. The Bootstrap is Bootstrap pod, the one and only instances within a Bootstrap service. Within my applications, I can ask for a connection to Bootstrap service, and an internal load balancer will make sure I hit a live instance of it. Same for Redis. So there's 3 nodes of Redis running. I can hit this one cluster IP within my code here, and it will make sure that my request within this application gets distributed to the correct node. So for Bootstrap and the two Redis ones, that's all internal. I'm not exposing that. But for PyService, I want to be able to use it outside of the cluster. So I actually put a load balancer on it that has an external IP address. I'm not doing anything fancy like doing DNS with it because I want it to be quick. That takes longer if we've got to propagate DNS. So since paste isn't working, I'm typing it. 7, 8. Just do something simple like 100. So oops, did I get the URL? Oh, okay, well, it failed, as you can see, because I can't type. All right, so that's calculated 100 digits, which is not super impressive given, I think most of our watches could probably do better than that. Just give you an idea of what happens so you can see that there's no real magic. This is what the endpoint looks like. It's just v1 digit, let's say 1. And it just returns the digit, which is right here, 3.14. So 0 based, that's 3.14 right there. And a bunch of information I'm using for another project. That Py client that I used here, that deliberately issues 100 requests to try and get those digits and then puts them all together. If I try and do a few more 100, it'll probably start to fail because I've deliberately underpowered this cluster. Oh, no, that didn't fail. Let's try something more interesting.
Now it's
failing now.
Now it's not going to fail. Just
it's not meant to fail spectacularly. It's meant to fail a little bit. All right, this gives me better hope.
Is that the algorithm? Is that implemented in what, a Java file?
Oh, that's Go. So yeah. While it's doing it, while I'm waiting for it to fail. Yeah, it's just a stupid little program. Let me show you. Yeah, so here we go. So yeah, here it is. It's all on GitHub if you need to take a look at it. I don't mind sharing everything. But yeah, it's using this algorithm called, what did I say it was? I don't even put it in here. But there's a URL you can go to and they talk about it and how clever they all are for coming up with it and all the rest of that.
And yes, his GitHub username is memes.
Yeah, that's because I've been doing this long enough to grab that one. For what it matters, that's my IRC handle as well. Still on it, if anyone, yeah, I know I'm dating myself, discourse kids, but
Some nice real estate.
yeah. Like IRC and Emacs, that's where you find me. Exactly. So you can see here it's generating errors now. It's timing out. There are problems with it, and I'm sure I hope if I go back over to my cluster here, we're going to start to see some problems within this particular node. So take a look at what's going on. No, it's still quite happy according to this. Let's see. None unavailable. I'm surprised. Let's see how many restarts we've had. Okay, so now you can see restart. So this is when the Kubernetes is looking at these nodes, these containers, sorry, and going, are you alive? Are you alive? And if any of them fail to respond within enough time, it kills it and restarts it. So if everything was great, if we weren't getting any errors, the restarts column would all be 0. But obviously, things are happening. This is a stateless app. It's deliberately okay to kill it. It was not going to do anything to it. So I think this is appropriate, but we'd probably be better off just to let it scale up, forcing these things to happen. So that's one of the beauties of is that it allows us to do a lot more stuff like that. So let me bring back my Profile, oh, we've gone past that. We start to see errors, okay. So let's see if we're actually getting errors. Yeah, we're getting errors. If you look at some of this, again, for other reasons, I'm deliberately leaving hash signs wherever there's problem. Oh, it doesn't highlight, sorry. So it found some errors, but if we run it again, it comes back really quickly, and that's because it did calculate the digits. It wasn't a case of failure of calculation, it was an overload issue. So those numbers have been stored in the database, and it comes back pretty snappy the second time around. So what I'm going to do, so the assumption here is we just cannot handle the number of requests. Everything else is fundamentally fine. So I'm going to make sure now that this can scale up beyond that. So one of the things I did when I set up the cluster in that shell script is I turned on something called auto scale. I can tell Kubernetes, or GKE really, but Kubernetes under the, that I want a certain number of nodes to start with, but I can scale up to 198 in this case, if need be. Now, it'll only do that when Kubernetes tells it it needs to create a node. And as you can see, Kubernetes did not tell it to do that. There's one other step I've got to do. There's something within Kubernetes called horizontal pod scaling. That's when it can then inform the framework that things are going on. So I need to set that up, and that's done from the command line again, in my case, just by doing one more YAML file that defines the auto scaling requirements. So let me do that. Okay. Oops, wrong one. Let that do its thing.
So that's going to enable Kubernetes to horizontally scale then?
Yeah, so what it does is, I'll do it in, okay, so if I go back into, where is it? So it's an HPA file right here. Actually, let me go back one more. Let me look at the deployment for the Pi server. So when I set up the Pi server, what I did is I gave it some resource requirements. Okay, so what that does is it says, try and run this with 250 bytes, essentially, of memory and a quarter of the available CPU power on this particular virtual machine. But I can burst up to double that in this instance. Okay, so the Kubernetes will do the best it can to do that. So you can mix and match real numbers versus factorial type, not factorial, relative numbers. But what I'm doing here is saying I want to do quarter up to a half of the available CPU power for this particular deployment. When I to add in HPA, which is the horizontal scaling, I'm saying that, I want to keep a minimum of 5 around, but I can go up to 500, which I know I don't have that many nodes in this cluster. It's not going to let me do it. But theoretically, if I called Google ahead of time and said, hey, let me run 500 nodes in this demo, that's what we could do. But every time the percentage CPU gets above 30%, it'll start launching. It'll tell Kubernetes that, hey, we're under load here. GKE should then launch another node or more nodes in order to satisfy the load. So let's see if that's gone through. That's gone through there. Let me go back to my...
Part of what we do is then visually. So you'd be able to see going up to 30 or whatever, and then dropping down because you have another node.
Yeah.
Spin that node up, what's running in that node, all in real time.
Yeah, exactly. So one of the challenges I have is just before you all started arriving, I was trying to find the numbers that would make it scale the way I want.
Yeah.
And it's a hit and miss thing because I don't have visibility into those numbers. I've taken a guess that 30% will trigger it quickly enough for a demo. And I'm hoping that's going to work. because I had it at a higher number and it wasn't very interesting. Let's see. So now when I look at the deployment, yeah, we've got our HPA right here. So it knows that this particular one, I haven't done it for the Redis ones. They don't seem to be having any problems. It's a stupid little database app. It's not going to cause any problems even for that. So now let's try and generate some load. And I still think it's probably going to fail on this machine, but let's see if we can get some stuff going. All right. So I've asked it for 1,000 digits and probably have some issues. It's already starting to have problems, as you can see. It's whether or not it will start scaling it quickly enough. Actually, need to do one other thing. Yeah, we're starting to see errors there. Hasn't kicked in yet. Do the right thing. I should have been more aggressive again. Let's let it run for a little bit and we'll see it start to scale. Let's see. Come on. Still at 0. So one of the things we do get from Kubernetes isn't Google's cloud platform, but something that comes from Kubernetes, is that there is a basic dashboard. It's not quite as advanced as we'd like, but I can take a look at it and hopefully we can see some more interesting things happening. Come on. Still plenty of failures. I can see it's starting to scale it now. So now it's gone to 6 because it's noticed that there is 120% out of the 30%. So it's going to start to ramp up. I just didn't change the settings to be aggressive enough to do it in a smooth way for this demo. Sorry about that. But you can see that it's going to kick in. It's going to start adding more and more nodes, which means that more and more instances will run. So let's see how many nodes are we running right now. No, it's still at 3. Looks like we're not going to be playing. The gods of demos are against me today. Because cluster size is not increasing like it's meant to. Like it did an hour before this started.
Performance anxiety.
Me or the
GCP.
GCP? Okay, good answer, Kevin. You're not fired yet. All right.
Maybe one day.
Yeah. Yeah, it's not doing it aggressively enough, but you can we can see with plenty of errors. I think that'll probably succeed now. All right. All right. So my auto scale did as I was hoping today. Yeah. So that I'll have to dig into that and put an update up onto the site that shows it happening a little better than this. Let me go back to, so with that in mind, I will continue as though nothing had happened. Oh, there you go. We're at the end anyway. Thank you. That I've done today is available on GitHub, and I'll be publishing the notes and the slides and everything else to the group. I appreciate your feedback, everyone. Let me know. I'm doing this the second time I've done this meetup, so all feedback is accepted and appreciated. Any questions or discussion points about what we saw today?
I have a lot, but I don't touch code, so this is, I got an interesting perspective into what you do, but I'll probably talk to you tomorrow.
Absolutely. Dinesh was convinced I didn't do anything around here,
Once in a while. So what did you do yesterday?
What did you do? Well, that coding you're doing, why didn't it work, Matthew? No.
What's like the pricing for running something like that? When it's idle, when it's at full capacity?
So one of the things I did there, and I talk about that more interesting, is all depend on how long it runs, right? So that's the key thing. One of the things I did here is do what do we call it? Preemptible. So one of the options you get in Google, I don't know if everyone's familiar with this, but Google's very aggressive on their pricing. They have a preemptible instance that's kind of like a spot instance. I mean, you don't have to wait for it. It's just always available. The caveat is it could die anytime within 24 hours. So if Google needs it for some other reason, someone who's paying more money, you lose your instance. If you leave it running 24 hours, it's dead at that 24th hour. But for things like demos, that's what I use because it doesn't cost us very much, and we can calculate it. Let's see if I go to, oops, dang it. Sorry, I should have done here. There I go, console. No, I should know these by heart. We can actually start building that up and seeing what it would cost. So I tried products, plural. Come on, Matthew. All right. There we go. I'm going to kill some things that aren't. Let me make it a little bit quicker by killing some of these things.
At least it did it.
Yeah. Oh, it gets there eventually. Like my mum's Yugo. There we go. So container engine, you can go in and say, okay, I wanted, what did I say? I think the top was, I started at 3, yeah, but 3 is not very interesting. I think it was 198 was spun up to, yeah, it was a standard. Local SSD was 0. I did do it in Oregon. Not that makes any difference. Let's say it's running 24 hours a day, days a week. Let's go back here. Those were deliberately just 20 gig drives because I didn't want to. And add to estimate. So that would have cost me $5,000 a month to run 24/7.
Well, I mean, if you're a large company, that's kind of like pocket change.
Well, we did. I can't say too much. With some of their other products, that's nothing. We are working with an advertising company that needs to ingest and deal with a lot of data streaming. We were looking at $500,000 a month just for that. If your business needs this, that's cheaper than you're going to run your own data center. By a large way. And this is running 24/7. We wouldn't. That's 198 instances.
That's like a year of college tuition in a month.
Yeah, could be. But what we tend to find is that if you really need that many VMs, you're doing something special anyway.
Yeah.
What we tend to see is you start doing the auto scaling and you let it go up, you let it come down to 1 or even 0.
Because you might only need the 3.
Yeah.
Yeah.
Certain times a day.
Much more than that.
So if we go back to 3, you know, obviously it's a lot less than that, right? Yeah, now we're at $70 a month. You know, for 24/7. But the way we try and architect all these things is that they run, they stop. And that's how most of Google's products, when you look at Google's products as compared to, say, Amazon's or Azure's,
Yeah.
you're looking at products that are designed to spin up, do something, spin down. Data flow, you need to do batch processing or stream processing. Don't run a cluster, tell it what you want to do. It spins up a bunch of machines, shuts down. BigQuery. You throw its data, you ask for a query, it figures out the machines that are necessary to make that happen, and that gives you a result, and you're done. You pay for what you use, truly paying what you use rather than what you think you're going to need.
Nike's one of our customers, and they launch shoes, and they see just a tremendous spike because they don't last very long, and they do all these specials, and they do specials every day.
Right.
They'll spin it up, and then they just spin them down.
Exactly. So if you're making a data center, how do you do that? You send them back to Dell?
Yeah.
It's
We only
completely
need these
different.
servers between 2 and 5 p.m.
For the Best Buy, like, well, all inventory and return.
Exactly. You know,
But you also see it more with microservices though too.
Yep.
Right?
yes.
Yeah.
Yeah.
So they're a lot more ephemeral in nature than.
Exactly. And this is definitely a step. I think this is the state of the art right now. The functions is where it's going to be. I mean, you know, I hate to say it, but Azure and AWS are ahead of Google when it comes to the functions. You know, I did a presentation on it last month. There's only so much we can do. I mean, it's great for gluing their APIs together, but there's not a lot else you can really do with it at this point. But at some point, they'll support Go, they'll support Python, they'll support all the standard languages, and then you really do have a viable alternative to spinning up a cluster. Just let it sit there and spin up when it needs it and die when it doesn't.
Here's a question.
Yeah.
Oh, yeah.
You had trouble getting it to scale up,
Mhm.
but like the to scale up, what's the easiest way to pre-scale it?
So you can definitely do that. You can go into any of these environments. So I've got this environment here, let's say, this cluster, although I've already defined it as being a 3-node or 6, it finally upgraded to 6, look at that. Although it's now at 6 when it started at 3, I can go in and edit it, or I can upload the YAML file with a change in it, and it will propagate through. So I can go right in here and go, okay, I know I need more than 2 nodes in each of my zones. Right now I've got 3 zones, 2 nodes. I want, 20. Whoops.
It's something you have to rig up or do it manually?
No, this is an example of doing it manually. If you tune the autoscaler right, and you don't have the thundering herd problem I deliberately put in its way, right? I mean, very few workloads go from 0 to 1,000 requests from a little machine. Scale that up as you like. But very few real life things go like that. Your Black Friday events, certainly, if you do ticket sales, yeah, absolutely. So if you know that you're going to need to scale up on certain days, you won't do it the day before. So, Black Friday, Cyber Monday, the day before you go in here, you upload a file or you do it through the console saying, I know I'm going to need 4 or 5 times as many. So let me start that.
But the idea is that you tune it correctly and you don't have to, right? It just
Yeah, but that's where tools like
So-
SignalFX come in. But yeah.
So we'll do like predictive analytics to say, here's when you're going to run into issues, so you can preempt that.
Right.
Or even have webhooks out to then have somebody remediate it automatically.
Absolutely, yeah. Everything we're talking about is reactive as opposed to
Yeah.
predictive. Yeah.
That'd be an interesting topic.
What's that?
Reactive versus proactive with autoscaling and all that.
Sounds like something you should be presenting on.
What's going on with Friday lunch learn?
Don't let me do that. All right, let me just see if it shouldn't get me in trouble. I'm curious if the auto scaling will kick in, bring it back down again. But I'm trying to do 60 nodes now. Let's see. How many we got? Oops, come on. And it's already up to 24. I think that's probably a fight between what I want and auto scaling saying we don't need it anymore because the auto scale is still there. There's some questions. Yeah. So I need to go out and buy a MacBook. I'll give this one to my wife.
You always suck so many stickers on it.
I'll give it to my kids. I'll keep it on my desk for when Google come around. There you go. Also, we still got some time if anyone wants to hang out, talk about anything. But I do want to thank you all for coming. Thank you.
Yeah, thanks for hosting.
the
This is great.
feedback.
Thank you, Matt.
Welcome.
Thank you.
Yeah, of course. And I will make sure all of this is published up and online.
Is this you? Yeah.